CFT. Previously, we have discussed about the postulates and the main points of the theory, and today we will get to know how to draw the structure of CFT molecules. Okay, now first of all, every ligand brings lone pair of electrons. It's electron rich, and metals is also having the orbitals to accommodate those electrons, and the electrons are also, having certain exposure. So there is a repulsion between the electrons of a ligand and the electrons of the metal, and because of this repulsion, right, this is the sign of repulsion, right, they repel each other, right, and because of this repulsion, ultimately the energy of this d orbital will increase, and they split into two categories. The one which is having the high energy, another one is having the low energy, right. So technically they are called dx square y square and dz square is termed as Eg, right. If and the second one is dxy yz and zx, they form T2G orbitals, right. The energy of Eg and T2G depends on and the splitting of orbitals depend on so many things like the oxidation state of the metal, or the dipole moment of the ligand, and the which kind of a metal we have, right. So the nature of metal. Okay, so Eg will suffer more repulsions, right. So it will get in energy while, because they are present on axis of the ligands, and the T2G is having between axis, so they suffer less repulsion forces, right. So Eg will have high energy and T2G will have low energy, right. So what will happen because of these forces, right. So we have two kind of a ligands: strong ligand, weak ligands, that we have discussed in VBT as well, right. There's specific series like spectrochemical series, which explain the field strength of different ligands, right. So this is the general trend of some ligands. At the same time, strong field ligand is having the more crystal field splitting as compared to the weak ligands, right. Okay, to determine the energy value of T2G, we have 2 by 5. This particular one is called triangle with this knot sign, is called crystal field splitting, right. And crystal field splitting in T2G is the value is that decrease because of repulsive forces. The energy of T2G decrease, so it's decreased by the factor of zero point 0.4, right. And while Eg increased by the factor of 0.6, right. Okay, so crystal field stabilization जितनी ज़्यादा होगी उतनी ज़्यादा stability होगी. It's good to have a crystal field stabilization energy. I've explained in the previous lecture that crystal field stabilization energy decides the geometry of different molecules as well, right. Okay, what will happen now? See the structure. Firstly, because we have 5 d orbitals, you can count 1 2 3 4 5, right. So these d orbitals, you can name them, right. Dx square y square, dz square, dxy yz and zx, right. And because of the repulsive forces, the energy will increase, right. From ground level, the energy will increase, so they will get high energy, right. Then after the energy will increase, then they split into